Problem number 17. We have a function f of x. We're not told what f of x is, but we are told what its derivative is right here. We're asked for some questions. We're asked about some questions about f here. So part A says, where is f decreasing? So f is decreasing wherever the derivative is negative. Okay, let's figure out where that is. I'm going to make a little chart here. It should be clear that the locations we care about are, to check here, are -2 and 4 here. Because at those places, f prime of x is 0. If f of x, if x is less than -2, so for example, something like f prime of -3 will equal -3 minus 4 squared times -3 plus 2. Positive times negative is negative. Let's check something between -2 and 4, like 0. So this would be 0 minus 4 squared times 0 plus 2. This is positive, this is positive. So that's positive. Now we need to try something bigger than 4, like 5. 5 minus 1 squared times 5 plus 2. This is positive times positive. This is also positive. So where is this decreasing? It's decreasing on the interval from -infinity to -2. Part B says, student writes, since f prime of 4 is equal to 0, there's a local extremum, either min or max, at x equal to 4. Is the student correct? No, the student is not correct. How can we tell that? So the function is going to be increasing until we hit 4. It's going to be increasing, and then it's going to be increasing again after 4. So it's increasing slowly, and then it slows down, so it's no longer increasing right at 4, and then it starts to increase again. There's neither a local min or a local max at x equal to 4. So that is an important note. Okay, where is f concave up? So concave up, this is discussing when is f prime of x, f double prime of x positive. So for this, we need to compute f double prime of x. We need to compute the second derivative, which we do simply by taking the derivative of the first derivative. Let's do this with the power rule. Power rule will come into play. Product rule is what I meant to say. This times the derivative of this, x minus 4 squared times 1, plus x plus 2 times the derivative of x minus 4 squared, which is 2 times x minus 4. Okay, let's analyze this. We can factor out x minus 4 times 1 plus 2 times x plus 2. So x minus 4 times 2x plus 5 is f double prime of x. Okay, so here we have two spots we need to look at, 4, and then we set this is equal to 0. This should produce x is equal to -5 over 2. Okay, so let's analyze this. F double prime of x is going to be 0 at these two values we just determined here. If x is bigger than 4, both of these terms are positive. If x is between -5/2 and 4, like 0, this will be negative, this will be positive. Positive to negative times positive is negative. If x is less than -5 over 2, this is going to be negative, this is going to be negative. Negative times negative is positive. Okay, so we see we have two inflection points because the concavity, oops, I'm starting to answer part D right now. Find the x-coordinate of each inflection point. That's going to be these values right here. What was part C? Where is f concave up? Where the second derivative is positive. So negative infinity to negative 5/2, union 4 to infinity.